So, okay, Arun has got a question. How to load files using column name having special characters like user login, etc. Okay. Why do you need to? It's not a column name. It is the name you are going to give. All right. So it is up to you. How do you name these variables? Okay. User space login is your choice. All right. So this is your variable, which you are going to refer back. So it's a variable name. Variable name, you can't keep a space in there. Just like in C, you cannot keep a variable name, a space in the variable name. What about the assignment is, let me have a look. Oh. Okay, this was just for the basically it was for the depiction that this column contains tweeted space message. Okay, it has nothing to do with this variable name. This will work. Yes, it will work fine. Okay. This table is the column names are just for depiction purposes. The variables are up to you, completely up to you. All right. Not yet. I've not started sharing it. Okay. Okay. So where were we? Basically, we had talked about this one, I remember, and we had talked about, I think, this also. There was some confusion related to this, right? What was that question I forgot completely regarding this bag, Arun? Why there are points mentioned in the assignment? Where are the points? Okay. So basically, each question is of 5 points, except for basically second A, it has got 30 points. Okay. So that while evaluation, we can, in case you have attempted, say, you have attempted 2A. If you have attempted 2A, you'll get 30 points. Okay. Hmm. Okay. 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 If a bag contains more than tuples, yes. Basically, a bag is sort of an array of tuples, and we can a set of tuples actually, not even array, because in array you know the order of things. Bag is more like a collection of tuples, and tuples is a collection of row values, column values. In a tuple, you can give names to each and every variable. Okay. So I think it's good to go now. Those who really want to join, they have already joined, and others are sleeping probably. Oh, okay. Okay. So inside a bag, actually, it does not make much sense to point to a particular number of row or a particular tuple. Okay, so the kind of function bag provides are very very different. So bag generally provides you with function like flatten, where it can convert your each uh, each field value into a row value. Say flatten is one such thing. So it doesn't provide you a way to basically refer to a particular value in a bag. Okay, okay. I'll just grab a water bottle. Just wait for a minute. Hi, good morning, everybody. Good morning, Ajay, Deepak, and Arun, Ratnaraj, and Savita Tuhin. So, Ratnaraj, what's your full name? Because you are not in my list. Okay. So here, tweet.data, it is available over here as well as it has been copied. It has been copied to data folder. Okay. And here you can see tweets.csv as well as users.csv. Okay. Similarly, whatever I'm experimenting with baseball and baseball one is available over there also. Okay, great. So where were we with respect to the session last time? What are the and Arun, was I able to answer your question? So basically, bag does not provide you much of a functionality, and there was a little bit of confusion when we say b.x, what will it return, right? Here, right? So basically, T is a way to define the tuple. Here, T colon means a way to define the tuple. All right. And here, B dot X means generate a bag of only the X value. Okay. This is when we say generate B dot X, it means generate a bag of values contained in only X. Okay, okay, okay. Hi, Iria. Thank you for clarifying that. I was wondering that who is Iria. Okay, 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 okay. Because if you see here, I will show you very, very quickly. So let's take, I have say a file called baseball one. There I've just taken a tail of baseball and just kept the last 10 records so that I can do it fast. Okay. And say I'm loading this. Not this. I'm loading baseball one. Okay. It has got name and it is supposed to have a team. So first is Ryan Zimmerman is the name. Then you have got team. Okay. And then you have got a bag. Okay. The team is a char array. And then we have got something, a bag of games, which they have, not games, something else. And we say that B is a bag of tuples. B is a bag of tuples. So the way we define it is like B is a bag of tuples. And under this, there is only one value which is being repeated. Okay. And we call it char array again. Okay. And if you, let's say, what does it have? Okay, okay, it is coming out. Hmm. So it has loaded all of that, and say we just want a particular value. I think I'll take another example. I'll take another example. I have created a myfile.tsv that is simpler to handle. Okay. So this file contains only the bag. Okay. This is the first bag as in first set, or you can think of this as a single row, and this is a collection of rows. This is a collection of rows. Each tuple in the square bracket is analogous to a single row. All right. So let's just take this example quickly. So in this, just to handle my local files for time being and run it in demo mode, I'm going to run it in -x local mode. Okay. So if I say load my file.tsv and say, so is it visible properly, or should I just increase the font value? Okay. So if I say dump am, so dump am has given us the same format again. Okay, whatever we had inputted. Now if we say for each generate a b dot x. Okay, and we say dump f1. Now only this will get printed. If you recollect, we have said my file contains basically a B, which is a bag of tuples of type containing two variables called x and y. X is a char array and y is an integer. Okay. So here it has only printed the first one. It has not printed the integer. Okay. So basically, whenever we say b dot x or b dot y, whatever we want to say here, let's say we want to say y comma x. Now it will just reverse the values of a tuple. Okay, it's like that. Does it make sense? No. So basically, this is our format where each row here, this is one bag, this is another bag. It contains one tuple, two tuple. Okay. Similarly, this second bag contains one tuple and another tuple. Okay. And when we say load this, it gets loaded into M, and the way it is passed is as is. Okay. So basically, the default loader from the pig understand this format very well. Now, if you want to basically flatten out, let me show you flatten out. Okay. So if you do this now, okay, like this, okay. So each tuple has become a single row. Okay. So the map, basically, yeah, what it does is any out of any bag, it takes out each tuple and put them in the row. That is what flatten does. Okay. So similarly, there are convenient features on top of a bag, which help you with these kind of things. Okay. Similarly, you can have like counts, but you can't refer to a particular element in a set. I think it was, no, I think it was size only. Could not resolve a method called count. I think there is a count method somewhere. No, it's right. So method names are basically capitals. So each one has said key there are two tuples in each of the values. All right. And in case we again run it, so basically I'm trying to show you that how to do various operations on a bag. Okay. This is a classic example here. Okay. Where I have created only a single field with a kind of a only the bag values, and each bag is containing, there are two bags, each bag is containing tuple, and each tuple is containing two fields. First is a string and other is a number. All right. Hope that clarifies a bit. Arun? So Savita's question is, if you did count method on a flattened file, it would return 4 or not? That's a good question. So let's just do that. Okay. So when we flatten, right? So because what we are doing is going over each row. When we say for each m is this, right? M is this. So we are saying go for each of m, meaning first this is the value in the for each, then this is the value, and then when we say flatten b, which means this goes to the horizontal row. Or let's talk about the count here. Okay, let's f4 equals for each count, right? So count would give us two values. This is 1 and this is 2. Now can somebody guess what will be the, if you say, I say here, uh, let's say I say for each this, okay, and we say generate count, what will be the output? So we have loaded everything into M, and I say f equals flatten, and I say describe f. Okay. So when we say flatten something, since flattening has renamed things, okay, flattening has renamed things. Flattening has created a new bag. This is a new bag in which there are two values, b colon colon x and b colon colon y. Okay. Whatever was there in the b has been flattened out, and basically if you say dump f, so this is named as b colon colon x and this is named as b colon colon y. Now if you are iterating over, say we say g is equals to for each what was the name, f, g equals for each f, and we say that generate for each f, generate b colon colon x. Okay. Now b colon colon y. Okay. And right, so you will get all those second values, these the second part, right? And if you say here, count, let me see what was there in, no actually, so we have got this whole set here, and we don't have a name for this. So we are saying, okay, we don't have a bag over there, right? We don't have a bag over there, and each one is a variable when we say describe f. So it has got b colon colon x and b colon colon y. But if you no, it won't allow you to do that. No, it doesn't allow you to do that. Basically, it doesn't have a bag per se. There need to be a field which name is which is a bag. Okay. Therefore, you can't do much about this one. Okay. Okay. Yeah, count works on a bag. There should be a method called size probably. Okay. Now, there's no method to actually count a value in a tuple. Okay. Okay. No, it doesn't give you the right value. Yeah. So basically, we are trying to say that count all the fields in this particular tuple, right? So hope I have cleared your question. So count is basically used in case of a map, not map, sorry, bag. Extremely sorry. So count is basically used on a bag of tuples. Any specific scenario for the method count in real time? I want to know how many items are there in a variable which I have loaded. If I have to do a count on key value pair, okay. So in this case where, yeah, in case of a map also, it is fine to have a count. It will work very well. Length will work, size will work. But in case of a tuple, it doesn't work that way. Okay. Yeah, in those cases, in that tweet.csv, you can do that. Okay. And right, the count and the length and the count and length will work fine. Here, what we're trying to do is here we are trying to actually count the number of fields in a tuple. Okay. That's not possible using the standard ways. Or maybe there would be some method to do all of that. Okay. Okay. So till what slide we were there on the previous day? We were talking about this we had discussed. So let's okay, so 39. Right. So okay. So on this slide we were discussing about, I think we had discussed the single join. So here we were discussing last time the join, right? Let's continue from there. Okay. Let me just turn down the volume. Okay. So, so I was trying here, there is a file called nysc underscore daily. We have loaded it as a tuple containing exchange symbol, date, open, high, low volume, low, close volume. Okay. And recording is on, right? Yeah. And similarly here, and we joined it by symbol, right? I remember I had described. So basically, join only happens either on a single value or a combination value, but it is always on equals. All right. It is never on, say, join this and this where A less than B. That kind of thing is not possible here. Okay. Those kind of jobs you are generally left for the filter. After you join, and while joining, unlike SQL, in case of SQL, we do not need to always provide a where clause. Here you need to always provide a column or a set of columns on which the a column or a set of columns we need to provide for on which the joins will happen. Okay. So here, if you look at this one is basically a join on a single column called symbol, symbol from daily, symbol from divs. Okay, while this one is a join from symbol comma date from daily and symbol comma date from divs. And these column names could be different. I mean, column names, or you can say field names of a tuple inside a tuple. Basically, this daily is a tuple containing these values, and divs is divs is also a tuple containing these values. Basically, uh, a bag of tuples. Daily is a bag of tuples. This is also a bag of tuples. And when we, you know, join this, then, yeah, okay. And we were talking about self join last time. That in case you try to simply join div1 and div2 as is, that's not possible. If you try to join uh, daily with itself, then it will give error. Instead, you can load the same file twice. Okay. Here, if you see with these two rows, they are basically same. If you join them, if you load them twice, then joining them is possible. Okay. But in case you try to say join divs1 by symbol with divs1 by symbol, then it will give errors. Okay. Basically, it will not give error, but in the end result, you will not get the correct output. Okay. So if you have to do a self join, you have to load that file twice. Okay. Mm, no, Savita. Actually, it loads. Bag loads with these brackets. This is my bag. It loads with the curly brackets. All right. Map is fine. Map is you're right. So bag is in the curly brackets. Bag is basically collection of tuple. A tuple is nothing but values in a predefined field format. Okay. You can think of bag. You can think of tuple. You can think of tuple as a single row of a database table. Your tuple is sort of a single row of a database table. And a bag is a collection of these tuples, which means bag is sort of a row set. or you can bag is sort of a collection of rows. Okay. So this slide will give you a clear idea. Like bag is always in this. I'll also show you in this. Okay, that will be better to do. Baseball one. Okay, here this file, each row. Let's analyze its single row. Okay, let's analyze its single row. This one. So it has got first one is a name, second one is the team name, and third one is a bag of certain values. And this tuple only has a single value. Okay. And this bag has only a single tuple. Alright. And this is a map. Map has got always the key value pairs. Okay. Alright. Is it clear now, Savita? So bag starts with the curly brackets. Okay. Here. And a tuple starts with the round brackets. This is a tuple. Okay. Or you can actually take an example from this one, will be a better idea. Okay. This one is also a good idea. Yeah. So there is one value. This is a char array. This is a char array. And then you have a map. This map has got two tuples, one tuple, two tuple. These each tuple is having only a single value. Okay. And this is a map. All right. And in this case, this is one bag. So the describe this should say byte array, bag, and maps. Yeah. So let's just show you that. Okay. How should I? Yeah. So basically, if you have this sort of file, and so if you say describe in this case, it is basically saying that M is a bag. M M is bag of tuples. T colon is tuples, and B is the name you have given over here. Tuples where X is a char array, Y is a char array, right? No, I did not get your question, Savita. Okay, 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 great, great. Anybody else has question regarding the map and tuple and a bag? Feel free to ask. I have the examples ready, so I can explain right away. Tuhin, Tranmin, everybody's clear about bag and tuple, right? Okay. All right. So again, all right. Now there is some interesting things other than limit. Limit is like a standard way of doing things. Okay. Limit means that, yeah. So limit is equal to your standard SQL syntax where we want to say that we just want to see first n number of rows. Okay. That is limit. All right. So here you can say limit and you will only get those values. Okay. Only 10, 10, first 10, whatever you define here. So when we want to just get first 10 values out of div, then you can say limit div by 10. So you get first 10 rows out of it. All right. Now there is some interesting syntax called sample. Okay. Sample basically says sample a random 10% records out of this particular map. Okay. So it's interesting to see that every time a sample will give you a random value. Okay. This one, I'll show you this. I think it is not there. Yeah, it is there. Okay. So if you say sample this much. So point one means 10% records, 1/10 records. If you say 0.01, it, it will be only 1%. 0.01, it's basically from 0 to 1. So fraction of records, how much ever you want to see, you can see. And this is a sample one, which means you'll get random records. This is good because generally you are dealing with a lot of data, and sample is a good way to just see only few records. Okay. So my next question is that, so we got this, right? We got only how many records? Now if I run dump again, if I run dump sum again, will I get same set of record or different set of record? There's a question. Great, great, great. No Tranmin, it will be different set of records. So although the sum has been assigned only once, but if you remember our discussion that every time you call dump or every time you call store, the whole thing gets processed again. Okay. The whole graph of the variables, generate, load, everything gets computed again every time you dump it. And nothing, actually, no action happens when you say sample. Actually, if you say sample or load, nothing happens. The actual work happens when you say dump or store. So whenever you are saying dump again and again, the sampling is happening again and again. Okay. So if you see earlier, we got first record as 0.165 and CATO. Let's see what comes out this time. I think we can turn off the messages. I just have to look it up. Hmm, turn off info messages in pig. Oh, actually we have to create our own log4j file which can turn it off. Okay. Yeah. We can create our own log4j file in our folder, and we can say give us only the one label. Okay, and then we can run this. Yeah. So this time it's different. It's C and W instead of the previous one. Okay. Earlier we got different set of results. Where is the previous one? Yeah, yeah. We got CATO earlier. The first one, here it's something else. So this is a good way to actually see your results doing a sampling. All right. The one of the properties why we have pig not using standard SQL is the parallelism property of pig. Okay. Basically, every query tries to optimize as much as it can, because it has, as a basic philosophy of pig, it says that pigs can fly, which means it has to be very, very fast. And to be very fast, it needs to do a lot of parallel. So the one way to look at the parallelism is controlling number of reducers. Pig helps you control number of total reducers. Okay. And say you are running a group by. Okay. Group by will basically internally create number of reducers. So group by supports a syntax called parallel 10. So automatically it will create 10 reducers. Okay. And then it will give you the output. So this will help you do the task very, very fast. So everywhere, whatever syntax you have used so far, most of the syntax supports additional syntax called parallel, and you can define how many parallel ways do you want it to do. So based on number of nodes available in your network, you generally choose the value of the parameter here. So if you have 10 nodes free available, so you just generally say parallel 10. If you have just one node free available in your network, you say that one. You don't need to do a parallel then. Okay. So basically, when it is grouping these values of New York Stock Exchange daily, then it will basically create it in parallel. Okay. It will, when you're running the group on top of this one, it will run the grouping in on 10 parallel machines. Okay. So if you remember partitioner, if this is the job, or this is internally making 10 partitions and executing group. Okay. So basically, when you think about this line, right? When we say load this as this, okay, and then you say group. So basically, this will run a mapper, okay, which will load each of these values line by line, and then that mapper's output will be given to a reducer. So anyway, so this one group daily by symbol, okay, group daily by symbol combined with the first syntax will create a mapper which will a map function which will create key value pairs. The key is the symbol over here, and value is the whole row. Now when you say group daily by symbol, so the first mapper will give out the uh, key value, key as symbol, and the value will be the whole row. Okay. And once you run it, once the and the reducer will do its job. Okay, here, and basically, Okay, let me try to explain again. So Savita, this is just for example purpose I have taken. Okay. You would not require 10 reducers in general, but if you have a requirement and if your reduction process is slow, in case you are doing a lot of things, then if you have got a lot of data and a lot of free nodes, in those cases, you might want to go for so many in parallel. Okay. Okay, so let me try to simplify what I'm trying to say. Okay. So if you think about group by, okay, if you think about group by in pig, it is equal to creating key value pairs based on the symbol. Okay, your key is symbol and value will be the whole row. All right, and as a result of grouping, say you have got a data like this, a comma 10. So you have got a tuple like this and a comma 20. Okay, this is, let's say, is in your file. All right, and let's say that basically when you group by a particular value, what it does is it does the mapper and reducer for you. Okay, it basically converts, say when we are saying group my this is, let's say, my data set f. Okay, so group f by, say, a. Okay, it will basically create your group, whatever on which you have grouped by, and and tuples like a comma 20, a bag of tuples, and a comma 10 and a comma 20. Okay, so and here this will be basically a. All right, so it will create some sort of this tuple. Each one will be like this. Okay, so when you group this by a, okay, let's say that this field itself is also called a. Okay, when you are grouping it by a, what will happen is it will create a tuple in which the first value is your a and second value is basically aggregation all of the values together. Okay, all of the basically tuples together which belong to the same group. All right, so this is what grouping does. We had discussed earlier this part. So now for each key on which you have grouped, it has aggregated like this. And now to do the reduction, to do the further, processing, you iterate over the result of say the result G. You iterate over G using for each and then take the further action on top of it. All right. So basically, your group phase involves a reduce phase. Reduce phase as in it will basically trying to group these things together and then at later point of time, your function will be run. So in this group phase, if you say parallel 10, this process of combining together the values, here we have combined the values together, will happen on multiple machines rather than a single machine. And that you can control, the number of machines you can control using parallel syntax. Okay. If you parallel 10, that is what it means. Does it make sense to you? So basically that reduction process is what matters, is what gets parallelized. Okay. It internally decides on a partitioner automatically. Also, parallel statement, the parallel statement, this one need to be applied per statement. Okay. So whichever statement you want to parallelize, you want to control its, I mean, how many, in how many ways it has to be executed parallelly. Okay. So you will have to mark each and statement like this. In case you want to mark it in the whole script, then you say default parallel is 10. Okay. So this parallel syntax makes sense only if only on the reducers. In case of, okay, okay. So very good question, Twain. Thank you. So uh, the if you have the first slide on pig, we were talking about passing arguments. Okay. So to any of your pig script, you can pass argument from outside. Okay. From the command line arguments you can pass, or from the environment you can pass to pig. Okay. So preferably, I generally prefer it using command line, and whatever variable you define on the command line, those are available in the pig script. So you can have a number 10 on the command line argument, or you can have a config file which d- says that these are the number of nodes. Okay. And without the parallel syntax, one reducer is allocated for 1 GB of the input size. Okay, that's the general behavior of pig. Okay, which means even if you have a lot of nodes free and your data is less than 1 GB, it will not divide it in parallel. Reducer will still happen on less than 1 GB. So input size as in input size for reducer. Okay. So basically when say your map is returning some output and Hadoop is collecting this output. As soon as it gathers 1 GB of data, it will this data will be within a single reducer. The moment it goes beyond 1 GB and above, then more reducers will be created. That is the default behavior of the pig. Okay, that's the default behavior of pig. Okay, again, I want to understand whether you understand this phenomena where, so this particular code will produce how many reducers? How many reducers will this particular code produce? It is basically we are going over divs, generating symbol, comma, dividend into 10. Anyone? But why does it need to create reducers? If you have to write the same code using map and reduce, Do you need a reducer logic? So there is no aggregation happening per se, right? It is just one to one. We are reading a file. We are just giving the output. We are not doing any aggregation in as Arun says. So so there will be no reducers per se. Okay, it will be just plain vanilla maps. Okay, we are just mapping one value to another, meaning our symbol goes as is in the output and rest of the columns are not given out. And my the we are giving one more value called dividend into 10. That's it. So there is no aggregation happening. Does parallel clause have any effect in this? So does parallel clause have any effect on this? For the query which I just showed you, for each divs generate symbol and parallel 10. Anybody? So as I was describing over here, the parallel clause does not impact any mapper. It basically controls reducers. And here we discuss that there are no reducers involved in this process. And therefore, no effect. Yes. Thank you, Savita. Good. Okay. Therefore, it will not have any effect. All right. Now there is a command in pig, a function in pig, which flattens the data. Okay, the way I was just describing to you. So let's say this is our file containing name and the languages people know. So here Sandeep knows C, C++, Arun knows Shell and C, Chintamani knows Java and C++. So we loaded that data. Okay, and we say name of the person, and languages is a bag of tuples containing a single variable. Tuples contain a single variable here called programming language called P. Okay, it's a bag of programming languages. Okay, now so what we are doing here is for each X generate name. Name is Sandeep, and flatten the languages. Okay, this will generate something of this sort. All right. So basically for each name it has created uh, it has flattened it. It has flattened this bag. It is just opposite of grouping. Yes, reverse of grouping. Reverse of grouping are there, not mapper. Yeah, you can say that actually, ma'am. Okay. So this is what is the job of flatten. And this is a very, very important phenomena whenever you're grouping and grouping. First, you do a group this one, and then you come out with the results, you process it, and then you say flatten some things. Okay. Does it make sense to you? Okay. So, yeah, I think you should give it a try and you'll be able to do it easily. There's nothing much to it. It's just opposite of group. All right. So here we have something called external function. So there are a lot of things which are not possible using pig. A lot of functions are not there. There is only limited functions which pig has provided. Although pig has done a marvelous job by providing all sorts of functions. But from time to time, you might need to create your own functions. Okay. In those cases, there are multiple ways to do it. You can do it in Java, you can do it in Python, right? And this is the general syntax. Okay. So basically, here you are saying define hex. Hex is the name of function which you are defining, which is nothing but invokes this particular function, static function of Java, okay, static function of Java, which returns int, okay, which takes up int, okay. So you can basically do this, okay. So if you have a function, this is from the standard library of Java, okay. So we are trying to say that java.lang.integer dot to has a string. We can execute this function with the name called hex, and we can use hex everywhere. Okay, we can use hex everywhere. And in case you have, and here it has done its job. It has done the hash of each of the values which I'm passing. Okay. Similarly, in case you have your own function, you can register that one. And you can similar way, you can say define my function which does this. Okay. Which does this. And then you have in a similar fashion, you can also use Python. You have coded a lot of logic in Python, and then you can basically register your Python code and then use that function everywhere. Like here, we have registered python.py, this production.py as bball. Okay. And now bball is now my class, I mean the whole file. Under that bball, if there is a function called production, then that function will be called here and used. Okay. So basically what I'm trying to show is you can use internal Java built-in functions, as well as you can create your own functions and use them inside your pig script, as well as you can use a Python script in the similar fashion. Okay. Now there is one more thing in case of a pig, which is for each. For each is fine, but for each nested we are talking about. So let's say that we have to find the count of distinct name in each city. All right. We have to find count of distinct names in each city. Can somebody tell how would you do? So this is the city name. These are the city name. This is the person name. We want to find the distinct name in each city. Distinct name as in Bangalore, there is only two distinct names, Sandeep and Vivek, and hence the count is two. And in case of New York, there is only one, John, as the distinct one. Okay, so you have to tell how many distinct name exist in each city. Anybody? How would you do it? Group by city first, yes, and yes. So basically, there are two group by involved, right here. In these cases, it is very easy to use something called nested way. Okay, so nesting is exactly for a case where you have two level of nested group. So for what you do is first you load the people like this. Okay, so we loaded people into a variable called people, and it has got it is basically contains tuples. First one is the name of the city, and second one is the name of the person. And then you say group by, and you grouped by the city, right? And here, while iterating over group, while iterating over group, what you did was you computed the distinct names, and then you did the count. Okay. So here, what you did was counts equals for each on this group. So for each of the group you have just created, get the name of the people. Okay, people dot name, and then you'd say distinct names equals distinct names. You create computed the distinct, and then you say generate group, whatever group you had here, whatever basically your group was city, right? City, comma, your count of the names. So this is the standard syntax of nested for each. Okay, does it make sense to you? So generally the syntax of for each is for each group and then name of the group and something. But here you are doing computation. You're doing some aggregation for each of the values. You're doing that computation, right? So for this kind of syntax, this kind of situation, Pig provides you a syntax whereby this computing the distinct on the values itself can be done in a very seamless manner. So for each nested internally, this also when you are computing distinct, this also is done using map and reduce. So even if your names are too many for each of the value, map will, pig will take care of it very well. Okay, does this make sense to you? Yes, no? Okay. Okay, this is an interesting phenomena where we call it fragmented joins. Say you want to translate from name to country to another table which has two columns, name and code. Basically, we are trying to translate the country into the country code, right? We are trying to translate uh, this into this, right? So one way would be to create another uh, file having the mapping of country to country code, right? and then we join with this one. Then we join with this one. Now, when you do this, it is going to be very inefficient because it is going to create those maps and reducers. If you remember the way we joined two tables together, when we join two tables together, what happens is that uh, the key on which we are joining the two tables, the same key, the maps will execute, mapper will, give out or print the same key whatever you are providing in the join. Okay, so and on the both the tables, and then combine that output and together and then produce it, right? So this is in case in case this mapping between country to code is very very small, say 200 records. Wouldn't it make sense to load this mapping into a memory on all machines and just go over the records and keep replacing, right? Instead of going with a mammoth map and reduce, okay, whereby you are generating key and value based on what column you're grouping on. Instead of that, instead of that, if this second table is very small, okay, if the second table is very small, we can simply load it into the memory and iterate, run just a simple map from row by row and replace the values. Okay, so in such cases when second table is very very small, as small such that it can be loaded into memory on all the machines, in those cases it makes a lot of sense to basically not go with a standard join. Instead, Instead, load this second file, which is quite small, into the memory and just run a single mapper, or just go by record, replacing the values, looking up into this new set, right? So for such cases, Pig provides you fragmented joins. So what you do is you load persons into person and country code into another table. So we have got two tables called persons and country codes. Now when you are joining these two, you can say that replicate the replicate the CC. Okay? Replicate the CC, which means that whatever is there in the second table is going to get loaded and copied all over the nodes wherever the persons table exists. Okay, so ideally whenever the join happens, using pig, what happens is that the field on which the join is happening, the mappers give out that field as the key and the value as the whole row, okay, for both the tables. Okay, and then since both rows will have the same key, and and then Hadoop will try to aggregate these values together. Okay, so effectively, normal joins are basically the complete map reduce phenomena where there is an aggregation involved. Instead of that, in case your second table is very very small and it can be loaded into memory, so you could basically run a simple job which just reads each of the file and gives out the value with the new replaced value. In such cases, similar thing can be done very efficiently using pig by marking your second table in the join as replicated. Okay, so here we have said that our country code table is replicated, which means it can be copied all across the nodes and all nodes can do the computation. right? So this is one important aspect. It is basically an optimization step. All right, it's an optimization step to guide pig so that it can take the right decisions. Because you know more about data, more about your data than pig does, and therefore you can take a better calls. All right. Now, in case your data is very skewed, is what does it mean by skewed? Skewed means that for some keys there are a lot of values, and for some keys there are few values. And when we say lot of values, it means more than 100 times. So one is having, first key is having just two values, and the second key is having say 10,000 values. So in these cases, you say that my data is skewed. Okay, and this skewed is quite a popular phenomena in today's world, specifically in case of big data. Having the skewed data is not something very unusual phenomena. It is quite possible. Okay, it is quite possible, right? So in such cases, if you know that there is a basically there is a chance of skewed data on a particular key. So when you are it is grouping on a key, and you know that while joining it will be too much of mess, because when joining or while running reducer, if one server gets so many keys, one server gets so many keys that it can't handle, or say there is one node which is getting all the values of a single key, right? And all these values are so many that a single machine cannot handle. In those cases, you have to mark this kind of table as skewed. Okay, so this join is skewed because in case in users table or city info table, there are so many variants in the city in the data, such that there are uh, that one machine can get too much overloaded. Okay, in those cases you just mark it as skewed. Okay, and rest of the things pig will take care of by itself. Okay, and there is a very interesting step which pig further provides you, is when you are already joining the two tables which are sorted by a particular key. Okay, so it is a common phenomena. It's a common phenomena when you are already joining the two data sets which are already sorted by the same column. Okay, you know that the data is sorted, so you know more about your data than pig does, and pig provides you a way to exploit. So ideally, which one did you not get, Raz? Which part? Skew data. Okay. So skew data, first of all, skew data means for one key there are only few values. For second key there are so many values. Okay. Which means when the reducers are running, and if one key is going to one node and another second key is going to another node, the second node will be over flooded. Okay. And may not be able to handle this kind of data. In those cases, you mark your data as skewed. Does it make any sense to you? So are you guys clear with respect to skewed data? Right. Let me go through the questions. Okay. So Ajay's question is, what will pig do in case the data is marked as skewed? Yeah. So let me try to answer. Okay. So what will pig do if it is marked as skewed? So what exactly will happen if we mark skewed? So can you give us example? Are you talking about skewness within the values in the user table, or C info has less data and users has more? Okay. I guess if you have two such table, can you show it, make it more clear? Okay. Will it divide data uh, of a single for a single key more than nodes etc? The example here seems like a case of fragmented join where where CInfo will have a small set of values compared to the user as and users. Okay, I think that's why my confusion is okay. So let me answer you first of all. Okay, S- okay. Just remember that no matter what, it would not split the data of one key on multiple machine. Okay, for one key it will not split the data onto multiple machines. What it will do though is that basically it will roughly prepare a histogram of various information available to it. Okay, and based on that, what it will so basically if there are key 1 which is having 1 million rows, key 2 having say 10k rows, okay, and key 3 having 2 to 20 rows, okay, key 4, okay, key 4 having say 30 rows, okay. So this data is quite skewed because these two rows are too big, okay, these many values basically, okay. Now these many values are there. Now in case it groups these two keys together, then it is extremely unfair, right? Extremely unfair, because in case it's, let's say you have two, it has decided on two reducers, okay? Two reducers, okay? Two reducers. And on first reducer, first one, it sent key 1 and key 2, okay? And second one got key 3 and key 4, right? It just went from top to bottom and picked first two, and then sent first two to the first reducer, and sent key 3 and key 4 to the second reducer, right? So this is basically very, very illogical. This is very illogical, okay? And therefore, it makes a sense to basically, instead of joining this way, on the first reducer, if it sends like key 1 and key 3, on the second reducer, it sends key 1, key 2, and key 4, right? Because here it is going to create 1.01 million rows, and here it is going to create only 50 rows, okay, which is heavily imbalanced. And there are chances that in the first case, the servers might crash because it is not ready to handle that kind of data. Or say you have got 2 million here. So effectively you have got 3 million rows here, right? So in these cases, it makes a lot of sense if it does a redistribution based on the histogram of the information available. Okay. So it does a little bit of basically after counting of the keys before before redistribution. Okay. It does a little bit of counting of the keys before redistribution. Okay. So that is, so if you don't specify that your data is skewed, it might end up with this. One node handling 3 million values, while second node is handling only 50 values. While if you mark skewed, then you can have both first one as handling 1 million values and second one having 2 million values. So this is what it does. Okay. This is what it does. And I'm not sure if there is some other optimization step which they have introduced such that they can compute multiple, run a single data into two parts. Okay. Because that's not possible actually. Okay. That's not possible to run a reducer on a data on multiple machines. Okay. What if the key one has 10 million and reducer can handle 5 million? So in those cases, there are, uh, you know, those combiner steps. Okay. There are combiner steps which which can run on each of the section independently, and then basically those can compute values, okay, in the parts. How it distributed is handled by pig, or can you also mention how it needs to be done? So basically the way pig has handled your data is he did a little bit of a uh, computation of first history based computation, second counted the keys, and then redistributed it. So right now it doesn't let you, specify that these keys go together, these keys go together. It only gives you this control that you can mark it as skewed. Okay. All right. So that is something about skewed. In case your data is going to be this way, then you should consider marking your data as skewed. Okay. Make sense? Did I miss anybody's question? I think I've answered. Okay. Okay. Now, second part I was talking about is that in case your say daily as well as divs, both are already sorted by symbol. Okay. Remember, sorted by the same key which I'm talking about. They're already sorted. Then you don't need to sort it again, because whenever you say join, it will have to sort the data and try to group it. Okay. Try to basically take the same value from both the sides and then combine it together. So join internally involves sorting of the data by the key on which you are joining the two tables. In this case, you can add an additional optimization step saying to Pig, hinting to Pig that hey, you don't need to sort my data, it's already sorted. Okay. So most of the data profiling you can basically, you know, how should I say that? So a Pig does not provide you right away data profiling tools, though it internally uses various kinds of histogram and all kind of tactics, but it doesn't give you all tools to do the profiling by yourself. Okay, so you might have to rely on your existing tools or rely on your knowledge of the data. Okay, so we talked about a fragmented joins whereby we mark a table as replicated, where one data was very small, and then second, when the data was skewed, when there were so many values for some keys, there were less values for other keys. So the way reducer has to work is it has to take care of this kind of skewed data. And third one is that already your data is sorted. So there were three cases, as Savita has pointed out, that these three cases basically took a benefit of your knowledge of the data, right? So you might have to use either your previous knowledge or previous tools or previous ways, or maybe another map reduce kind of steps where you are just doing a counting of various kinds of things. For those cases, you might basically have have your another set of tools or another set of map reduces. Okay, but also remember that Pig as well as Hadoop both keep a record of how much time each took. Okay, how many keys did one thing produce and all those things. So if you look at the debugging information which goes in the map reduce step, you should be able to figure out a lot of information over there. Okay, so that's the best we have right now here. Then something called outer joins. See, so probably all of you would be familiar with. Oh, thank you, Ajay, to remind me. Okay, let's take a 10 minutes break and come back at 8:50, 8:54. Okay. Oh, there's so much thing left actually. Don't worry. There are only few more things, but it is very, very important actually. Hi guys, I'm also back. Okay, so here we were talking about outer joins. Okay, outer joins are very similar to what SQL provides. Okay, okay. So outer joins are basically left outer or right outer. Okay, there are no inner joins per se. The default one is basically you can see. So so when we say left, okay, when we are joining A by ID and say left outer and say B by ID, right? Remember that we append this syntax on the first table, all right? First table, okay? Now when we say join A by ID and left outer, it means that even if on the left hand side there is an ID, okay, there is an ID here too, which does not exist in the right one, it will still come in the output. Okay, so basically it is joining A and B such that if the values, if the ID in A is not found in B, you still want that in the output. In those cases, you would require left outer. If you see one of the problems where I am asking that you should display 0 against the values here, if you see the expectation is that, okay, here, uh, okay, is 2, okay. So there is one problem which would require you to have the IDs which do not exist in the second table in the output. All right. In such circumstances, you use left outer join. Okay. So left outer join means anything on the left should definitely come. Okay. And this syntax exists only on the before comma, not after comma. All right. This syntax exists before comma, not after comma. So this is what is the left outer. Probably everybody is quite aware about left outer. So is it clear to everyone, or should I explain a little bit with more examples? Okay. Now there is basically left outer and left are the same thing because there are no inner joins. So this outer becomes redundant, like the way I have showed in the second example. The left, it is equivalent to left. Similarly, there is right one. Okay. Now this right says that anything on the right hand side should come even if there is no ID corresponding to that. So here first has ID equals 1 has is available on both the sides, while ID equals 3 is not there on the left hand side. So it will come with null values. Okay. So it says when we say right, basically says that the IDs on the right, IDs that exist on the right, when I say right means right hand, the table which on the right hand side of the comma. So we have join A comma B. Okay. which means by syntax, by convention, this is left hand side and this is right hand side of the column. And when we say right means give out the values of right hand side even if there is no id present on the left hand side. Okay, so you will see 3 comma saha without any values here. Okay, so to see the difference, this is 2 comma Ryan, while and this is 3 comma saha here. All right. Now, if you want to do it both, I mean left or right, if even if we basically we want to join both the tables and we want the IDs, even if there is no, basically it is like saying do the union. Okay. Not union in terms of database union, but in terms of set union. So it will put IDs from both the sides together in this format. Okay. And then give it out. Okay. So it is equivalent to left and right combined together. So 2 does not exist in case of full. 2 does not exist that side. So that side is right hand side is null. While 3 does not exist on the left hand side. So left hand side values are null. And therefore that is how it works. Right? So this is your question to you. What is the output of this syntax? Can somebody guess? Yes. This is a wrong syntax because this left outer or whatever syntax has to come on this side only. Okay. Now in this one, basically when we say join A by ID outer and P by ID, what is the uh, point? What do you think will be the output? True. Okay. Because outer does not mean anything unless you say that whether you want left, right, or full. Okay. Now this is clear to everyone. Okay. Now next one. Here there is something called co-group. Okay. I'm not sure if there is an analogous syntax in standard SQL, but co-group is a very handy kind of handy tool. So whenever you have to join by a column and then after joining that after joining two tables you want to group by the same column on which you just joined. Okay, in those cases it makes a lot of sense to do it in a single step, because when you join two tables you are anyway going to sort this data, and group by could take a benefit of this sorting if we are grouping by on the same column on which we joined. Therefore this is a single optimization step combining join as well as group by if both of them are doing a are doing operation on the same column. Okay, therefore pig team came up with something called co-group, where co-group. So you can see the output, right? So here there is owners table which has the person name and the animal they are owning, and then there is a pets table, the name of the animal and what is that animal. So in those cases we want to basically group by the cat. We want to find out which animal is being owned by who, all the people. Okay, so like cat is here in the output, cat is owned by Alice, Adam. Okay, yeah, cat is owned by Alice Adam, and here cat is owned by Alice and Adam, right? While just a second, this is I mean, okay, never mind. So similarly, dog is owned by Steve and Adam, okay, and these are the names of the dogs, Rex and Fido. Basically, we joined these two tables together and then grouped by. Okay. Does it make any sense to you? So here what we have done is we have basically quickly grouped it by uh, as well as joined it then grouped by. Okay. Right. Right. So same thing we could do is using our, thank you Savita for asking that. So let me try to break it into two steps. Okay. Let me try to break it into two steps. Okay. Okay. Now, so if I have to join it, so let's call joined. Okay. Joined equals join owners by animal and pets by animal. All right. Now, after you join it, you will get what kind of data? Now, the joined table would look like this. It will have uh, owners colon person, and then owners colon animal, and then it'll have pets colon. Okay, it'll have pets, right? Now here, so after joining, you will get this kind of data, right? Sorry, here pet means name. Thank you. Okay. Now, as you basically see after that this, if you say group by and we say grouped, I mean that this will be the format of the joined. Join will look like this. Okay. Now, grouped is something like group, group joined by say, and here, okay, joined by, okay, all right. Now, as a result of it, what will you get is grouped will have something called a group, which is nothing but this animal, okay, and then it will have basically it'll be look like this, and then you have one and another. All right. No, now uh, basically what it will have is this whole table like this exactly, and all the people belonging to uh, okay, so it will have something of this sort. Okay, it will have something of this sort. Okay, so it has got two rows belonging to the same animal. All right. I- okay, so basically I did a join by owners colon animal, and remember that it will be the same this and this, is going to be the same value. So either you group on this or this, it is the same result. All right. So this is what it does. Okay. So is anybody's mic on? Okay. So you'll get this kind of result at the end of time, right? I think I should have joined it properly. So is in the assignment part, is there a assignment? Okay. Okay. So let's say we have got, say, one table over here. Okay. And we say cat owners, right? And then we say, I think you should try it out by yourself. Okay. Try first the way I have just described. Try join and then group by. I think it will not be it will not give any errors. You will be able to do it correctly. All right. So basically, co-grouping is exploiting the optimization step, which can happen between a join and grouping if join and grouping is happening on the same ID. Okay. So one of the premises of pig is optimization, and optimization is very much required in the cases of big data, because a slight bit of optimization can give you a 2x return. And when we say 2x, it means a very very big deal, because it might turn your 10-day job into 5-day job. Okay. Therefore, optimization is very very important phenomena in most of the things. Okay, and it might your smaller optimization can become like say from few days to few minutes. Okay, and sometimes it becomes impossible without the optimization steps. So co-group is one such thing. So co-group optimization, then left outer join anyway is the need. Then we talked about skewed data, fragmented joins, and merging the sorted data, those kind of things. Okay. Now the next is the union. Union is quite standard way of concatenating two files. So and similarly, like union is basically equivalent of Unix cat file 1 and file 2, where the data contained in file 1 and file 2 is appended one after another. Similarly, there is a syntax in SQL called union all. So here we have, say, A table, B table. You can simply say union A comma B. All right. And so, and the other one is your union, basically, in case you want to force the uh, pig to use the same schema. In those cases, you can say union on schema A comma B. All right. And what does it mean by on schema? Is that basically it will try to match the keys from the two tables and will give you the correct output. Okay. It'll try to match the keys from A and B and will give you the correct output. Right. So I'll show you this. And I think I have A and B. Let's say cat A, cat B. No, this is not the one. Okay, okay, cat. Okay, ratings JK. What is okay? I think I had prepared all the examples and kept it somewhere. CT data. Okay, tail my file. Okay, this is fine. And then okay, actually I'm trying to see if I can give you a demo. So let's say that okay, okay, I don't have an example right away. Okay. So say you have got two columns. Okay. If you sorry, you have got say let me take an example here self. Okay. So let's say we have got ID and name. Actually, I can give you a good example. Oh, here. Okay, so we have got pets, and we have got people. Okay, okay. So let me describe. So you have got say two tables. First is this, okay, and another one is ID, comma, name one. Okay. And it has got also some other name, right? If you do a simple union all, okay, if you do simple union all, what will happen is you will get one and Sandeep and one and Salje, right? Just like that, okay? If you do that, it's as simple as that. Now, in case you say that on schema A and B, on schema as in on the basically if there is a schema over there, then it will basically create id, name, and again and name one. It'll create three columned output. Okay, now it'll have first Sandeep and this will be null, and then it will have one, and then it'll have null here, and it'll have name, sorry, it'll have Salj. Okay, it happens that way. If you are doing on, this is for on schema. This is for on schema. Does it make sense, Avida? Okay. Now, the way it used to happen in SQL, the join itself took care of the cross product. Okay. Join itself took care of the cross product. But in case In case you want to do that cross product, okay, in using pig, then you will have to use cross. Okay. So say you have got here, say we have got these values, right? And we want to say cross product between this is my A table and this is my B table. Okay, this is my A and this is my B, and I say cross A comma B. Okay, now what will it result is in ID name. Okay, and we have got again ID and then name one. Okay, so we'll have for each value for this side, we'll have one value from the other side. Okay, and let's say we have got two and say Giri. Okay, now we'll have one here Sandeep and two Giri. So this way there will be a cross product between the two. Okay, in case you have one more value, say here, say we call it 2 and we call it sen. Okay, in those cases you will have two more values here. Okay, 2 and here like this. Okay, so basically this is what the cross product will give out. Because this kind of property was well taken care by RDBMS simple joins, which was not possible in case of pig, because simple join meant a little bit different here. Therefore they had to come up with a cross product, and then you can do a filter on top of it to basically just get those set of records which you are looking for. Now now in real life you will have to inevitably integrate with the legacy code. Okay, say you are planning to do a translation of one value to another, and this translation exists in your legacy code. Now what do? You don't have that method in Java, you don't have method in Python, you don't have method in say your own Java library. It exists in some exe binary or say Perl file in the legacy code, which does this translation from A value to B value. Now you want to run this translation after your results are finished or before your results are finished or in midway. W- you want to run this kind of translation or this kind of function which exists in your legacy library code. And this is a very common phenomena when it comes to the real life. Okay, because most of your data and logic would be existing in the existing big store itself, and therefore they had to provide this integration. Okay, and so basically that whatever method you have, you can use it like a standard Unix filter, which takes input from standard input and gives out output to the standard output. Okay, it gives out output to the standard output and takes input from the standard input. Now once you have that in place, right, first, whatever legacy code you have, you will have to convert it such that it takes input from standard input and gives out to the standard output. And once you have that, you can import that using this. So I'm defining HD, and this is my hidev.pl. Also, also, okay, and you have to tell this. I mean, PAL file is located there. Okay. Now you will have to ship. Okay. Generally, whenever you're executing, whenever you are executing any Perl file, you might be having it already on all the nodes, right? In that case, you can simply run it like this. Okay, so you loaded your divs, all right? Loaded your divs from a table. Basically, you loaded dividends the standard way you were doing. Now, what you want to do is you want to the pass these values, pass these values, okay, through through your program. Okay, and whatever result comes out of it, you want to assign it to high divs. Okay, let's say it converts these four values into one value or two values separated by a tab. Okay, this syntax will call that Perl file or whatever legacy code you have. But problem occurs when this file does not exist on all the nodes. In those cases, you will have to use a syntax like this. Okay, you'll have to use a syntax like this. You'll have to ship it all together to all the nodes, and then you have to stream data through it. Okay, and these are the inputs you are providing to this. Okay, you are saying pass my divs through this program as these four values as input, four tab separated value or comma separated values as output. Okay, so this plays a very important role in case the standard pig is not sufficing your need. You can also write here your Unix command, just like in the streaming job. We can even write like bin wc word count. Okay, so this becomes a very handy mechanism in real life to handle a lot of situation where pig is not providing a way. They may be. So okay, is this clear to all of us? So basically, when you have a standard mechanism already in place, you want to use that one. Okay, all right. Now let's move ahead. Now, Tuhin was asking earlier a particular question where he was suggesting that do we have to do these kind of operations all the time or not? So that kind of requirement is quite common when it comes to reports or analytics. You run your analytics on different period of time, different for different users, for a different ticker, for a different variable, and all sort of things. So every time you run your analysis, you basically want a way to pass the parameter. So every time you are running a script, you run it like pig and then followed by your script name. And along with that, you can pass a parameter like pig minus p, and you can give the variable name. And inside your code, you can say filter daily by date and then define my dollar date. This will be picked up from the command line argument passed like this. Okay. Similarly, you can take all of such variables if you have more such variable and put it in a separate params file, and where you can specify all these arguments and then pass it to pig. This is quite useful. This is quite useful when you are having two different people, who one is an operator who runs these scripts from time to time for different values, and there is one developer who is developing these scripts. Okay, so this argument, I mean, all you have to tell the operator that either change this argument or in the command line or change in this file. Okay, so in case you are saving it in the file, all the variables, then you can use this way. And also in case of file, you can reuse the variable defined above in another variable, right? Okay, so this is parameter substitution. Now there is something called splitting. You want to split the data according to your own choice. Okay, although pig does a very decent job of splitting by itself, but still, in case you want to split by yourself, then pig provides you pig provides you the syntax by which you can split. So you say that you loaded wlog from a file, then said split wlogs into APR01, APR02, APR03 based on these circumstances. Okay. Also note that one record can go into multiple legs, and one record may be completely dropped based on the condition. Okay. And here we are saying store APR. So it created basically what do you say, three data sets. Okay, the way it created one data set here, it created three here. So one data set got divided into three data sets: APR01, APR02, and APR03. All right, and therefore, and also note that one record can go into multiple legs. Okay, based on your requirement. So this, in case you have realized that you can split the data better by yourself, in a more balanced manner as compared to pig, then probably you can use split command to split the data. Okay. Or you think that in case the your program, like when it computes the reduce and all those sort of thing, in case you divide this data into this format, the reducers will be more balanced than not dividing. Therefore, it makes a lot of sense to sometimes to split the data into various sets of your own choice. Okay. Okay. Also, in case of pig, the execution is not very linear. Okay, it is not very linear. Like this one, for example, might end up becoming a single map itself. Okay, and the output of which will be used by multiple nodes down. Okay, so basically similar to ant. Okay, similar to ant, you will have basically the execution is not from top to bottom, but it is based on bottom to up. Okay, so the moment we say dump x, okay, the above is computed that x is being based on the filter on y, and so on, and then filter y came from something else. So this execution will be triggered by dump, and it will execute only the things which it depends upon. Okay, so those kind of automatically the execution of pig is not straight away linear flow. Okay, and also based on the demand of the time, if you are joining, grouping, regrouping, pig tries to optimize by combining multiple passes together or splitting them into different ones. Okay, so those are the kind of things pig does for you. Okay, more about the documentation which we are following right now is 0.13 of pig. You can use the documentation to read further on various values, various basically various functions in detail. Okay, and try to finish the exercise given at the end. Okay. So try to finish all the exercises which are given in these sessions in the fifth session. Okay. So there is not going to be too much exercise today, but make sure that you go through Pig's assignment, right? Given at the session 4, 5. Okay. And we have given a sample this. So did you try to execute the sample project by yourself? Did you try to compile and then try to upload onto the servers and then try to run it? And also, with all the assignments, please submit all of your assignment as quickly as possible. Okay. Please submit all your assignment. Your assignment from session 2 and session 3 is still pending. So please make sure that you submit all the assignment, and because it will not be great to review at the end. Okay, so that in case there is a doubt, there is a problem, we can straight away rectify. Only few of us have submitted the assignment yet. Okay, so please submit all your assignment so that I can quickly review. And if needed, in case I have missed something and there is a wrong understanding or misunderstanding on few points, then I should rectify it. Okay. Okay. Because sometimes there are unexpected confusions which I never expect and they happen. For example, in one of my MongoDB classes, some people got confused between CAP theorem, and capped collections. So similarly, there might be a similar confusions here also. So in case you do not finish your assignment, okay, maybe you don't have got did not get a clarity on certain topic, and I may be of help. In case you are finishing your assignment, I may be of help. I can basically, instead of you saying that okay we have understood, I try to figure out from your assignment whether you have understood or not. In case there is a serious disconnect between the actual concept and your understanding, then I take a call and then we can maybe discuss further in a separate session, one-to-one session. Okay. So please make sure that you finish your assignment as soon as possible from beginning till now. Okay. And then we can discuss it further. All right. Now, okay. Yeah, Savita, I have reviewed your assignment last night itself. Okay, and I would like to discuss things further. I'll give you a call tomorrow after the finishing of the class, or you give me a call tomorrow at 10 o'clock, or you schedule a time slot. Okay, okay. Or maybe I can little bit wait and see other people's assignment, and those who have the similar kind of uh, you know, those who want, we can have the discussions together. So how can we submit assignment? You send an email to hadoop@nobigdata.com with your assignment. And in case of subjective uh, assignment, you create a Google Doc, separately Google Doc, and share it with me, Sandeep@nobigdata.com. Okay, you share that Google Doc with me, and and also give me the right permissions as well. Okay, so that I can include the TA and other people who can review these assignments. Okay. Now, basically, why I'm asking for Google Doc is because it becomes very comfortable to pinpoint things even while discussing over the phone, as we can type there and select there and mark various kind of sections. So it becomes very easy to pinpoint the problems and then solve. Okay. So do your assignment in your separate Google Doc, okay, and then share it with me, Sandeep@nobigdata.com, and give me the right permissions as well. Okay, so that is something. And now let me. So that's pretty much big. Okay, we have covered the whole of pig, and unless you solve these problems of pig, you will not get the hang of it. Okay, and that is the truth. Okay, okay. Not really. I mean, I'm planning to start a hive session today. Okay, and rest of the things we will continue the hive tomorrow. Okay, we are not done for today. Okay, so pig is finished. Pig basically takes two sessions. Okay, now Hadoop is great, pig is great, but how do you move existing relational and SQL infrastructure? The answer is you can't. Right now, there is a large user base of SQL users, DB designers, and also administrators. And on top of it, most of the data that we had been managing so far is of small in nature. Okay. So most of the data does not require, and some of the data is very transactional. Okay, which do not have plan to grow beyond a certain point and which is irrelevant after a certain point. In those cases, RDBMS, okay, should I, guys, so we have still 20 minutes left. Okay, so you can have questions. So, actually, we have still 20 minutes left. And I was thinking that I will just go over because I do not want to get too much into technicals of. I just want to do give an overview of Hive right now, and more technical details we'll get into tomorrow. Yeah. Okay. So we'll just go over the overview, and so basically, most of the data as of today exists in SQL. That is the real fact. Some exist in data warehouses, some exist in simply databases. So, and there are a lot of SQL users. Probably almost every developer with a few years of experience knows SQL. There are database designers, database administrators, and then there are people who basically execute query, developers who write the SQL queries in details. And on top of it, it does not make sense for a lot of database data to move to NoSQL or Hadoop right away. Okay, that data is happy there. Let it be there. Okay, but on top of it, doing a map reduce is actually difficult for even the developers, right? That is why people invented Pig, the people invented SQL, and all of it. So that people don't have to first learn a new programming language, because most of the programming language have a big learning curve. Okay. Second, in case of programming, these common tasks like union, filter, group, and join, they are very repetitive and time consuming if you try to code them yourself. If in the first chapter, that voting problem, the last problem where we are trying to do the voting, okay, we are trying to do the voting in that kind of problem. Basically, if you know if you try to code that kind of problem, it will be too much of hassle and too much of headache. Okay. And such problem, every time you see a problem and you see, okay, I need to join, it will be a pure repetitive job. Therefore, it made a lot of sense to come up with something like SQL or something like Pig. Okay. Now, SQL and Pig, the difference is that there is a lot of people who know SQL but not Pig Latin. Okay. And therefore, Hive makes a lot of sense. So Hive is basically a SQL query way of querying HDFS or HBase or other NoSQL databases. Okay, other NoSQL databases. Okay, so SQL is one way to basically, the gateway for the existing analysts to access the HDFS and query the HDFS. Okay, and it will be sufficient for most of the people. And so this is Hive is the main value proposition of Hive is it is very well suited for data warehouses. Relatively static data is analyzed. Okay, static data because Hive cannot insert or create data, it can only read data. Okay, now in the cases when you are dealing with static data instead of real-time data, Hive makes a lot of sense because under the hood, it is going to create MapReduce, which has a latency, and therefore, it does not make any sense for Hive for using Hive in case of real time. Unlike most of the queries, they get passed and everything is prepared under the hood. And the moment you fire a query, it does not recompile it. It is already compiled, everything is in place. But in case of Hadoop, the Hive basically executes MapReduces again and again. The way Pig was executing MapReduces again and again under the hood, Hive also does the exact same thing. In the cases where you do not require fast response, because there is a boot up time associated with Hive queries, and it makes very easy for uh, porting the existing projects. Okay, if you have already SQL kind of a product which runs a lot of queries, you have maybe a kind of a big large enterprise product which 90% of the job is it's querying the RDBMS and 10% job is querying big HDFS, okay, or some other system. So instead of rewriting everything, you can just uh, put Hive SQL there, and most the cases it will run as is. Okay, so say there was a data which was existing in your some other relational database. Now due to the load, due to the requirement, we had to move that data to HBase or say HDFS. Now you want to query it back in your enterprise application. In those cases, you can simply do a minor change in your existing SQL such that it starts querying this new location. Okay, and that is the value proposition Hive brings it. Okay, and also although the query language looks like exactly SQL, it is just a minor deviation from SQL, and we call it Hive dialect. And also, since the basically since Hive provides a gateway to almost all communications between various data stores, even MongoDB. If you guys have been following the YouTube channel, there is a demo I have uploaded where for my MongoDB candidates, where you can basically use Hive to query MongoDB from Hadoop. Okay, so since Hive provides a gateway to the NoSQL databases, which not necessarily have a schema. Okay, so Hive is supposed to provide a way to define schemas, because you might have to join the two tables together, one from the relational, other from the NoSQL. All right. So therefore, it provides a way to create metadata and of the table you are referring to. Okay. On top of the existing database, existing collection, you will have to provide a sort of metadata. Okay, here where you define the columns and all those properties, and then you map it to the MongoDB table. So whenever you query this table which you just defined with the metadata, you will be under the hood, you will be querying MongoDB or HBase or HDFS, whatever you define. Okay, so the way we defined in case of pig, say when we say load xyz as a comma b comma c, that's what we're defining the schema, right? Similarly, in case of Hive, you say create my table and then you say these are my columns. All right. And yeah, there are limitations to Hive. You Before we start Hive, you should think about it, so that you know what it is good for and what it is not good for. First, it provides no update, insert, or delete on record level. You can create a table, you can drop a table, you can, you know, insert few records from one table to another. Okay, and drop few records. Yeah. So, okay, here, yeah. So Hive maintains the Hive maintains a local file, okay, a local file containing all the details about the various tables existing with Hive. Okay, that local file could be in various databases such as MySQL and Postgres, and on our servers we are using a metastore which is on basically on Postgres. No, I think we are using MySQL actually. Yeah. So basically, this meta store, instead of storing it in local file, it just creates a local instance of MySQL, and there it keeps all the data. Okay. So it does not provide record level update, insert, or delete. Okay, but it can generate new tables, insert records. Insert a lot of records in one go, and it is not suitable for online transaction processing. Okay, because the queries have a higher latency boot up time, and Hadoop anyway is batch oriented, so most of the real time work does not happen over Hadoop or Hive, because there is a startup overhead for MapReduce job. As you can see, every time we launch a MapReduce job or pig query or any other query, it takes time to create MapReduce and start the process. All right, and therefore it does not make much sense to use it for the online transaction processing. And it helps you mine. It is best when you want to mine, and there is a larger data mine a larger data set which is being maintained actively. Okay, so all you want to do is you want to mine the data. In those cases, Hive does great job, and you want to mine multiple kind of data. Okay, so these are the general modules in case of Hive. So there is a something called Hadoop, which we all know already, Hadoop has got master, job tracker, name node, and there is a file system HDFS. Okay, and then there is something called Hive driver. Okay, and this Hive driver is like JDBC kind of a driver, or basically you can think of it as a main person, main binary which does your job, and you interact through Java via JDBC, and there is something called Hue web interface. This is not working right away. Hue somehow is not listening. Okay. So basically, the way you interact with Hive, this is the heart of Hive. This driver is the heart of Hive. This driver is the one which, when you give the query, it will compile, optimize, and execute that query, and will basically it will also use metastore whenever possible. Now, the way to interact with the heart or the driver of Hive is either through command line interface or through Hue web interface. There's a web interface where there's a text box where you can type the query and then say execute, and then it will give the output. Or through a thrift server. Thrift is nothing but a way to service oriented programming. Okay. And any JDBC, any JDBC is basically an any JDBC call is basically thrift server. And then there is ODBC. Okay. So, okay. So there are various kinds of data connectors over there. Okay. Here, most important thing is that we have got JDBC, and that is good enough. Okay. So yeah. Now let's move ahead. So if you have to do a word count example, maybe you can use it this way, but I'll stop it here itself today. Okay. As everybody has said that let's not overload. So we will discuss from the 10th slide tomorrow again. All right. And please submit all your assignment as quickly as possible. Okay. Okay. Thank you, Deepak. Thank you, Ajay. Thank you, Savita. Thank you, Tuhin. And bye bye. Bye bye, Raj. And bye bye, Iraya. And yeah. Thank you, Jimmy. Thank you, Prashant. Thank you, Tranmain. Tranmain.